Okay, today's lesson we are beginning 8.4. So in your pink booklet, if you're in my class, or if you're in Mr. Sutton's class, it's in your blue booklet, you are flipping to the back side of the 4th page. And this is what you should see. Here's the title, and here's the first equation we're going to take a look at. So this is the last section for chapter 8. Now we have some variables on both sides of the equal sign, which is here and here. And then we have some ding-ding-ding-ding class change. And then we have some constants here, and eventually we'll see some where we have constants on both sides. So let's just fill in the blanks here. Obviously we've talked about this. The goal in algebra is to isolate the variable. Okay, so you can fill your blanks in. This is not a new concept. All right, so what you want to do here is you want to try to get the variables on one side and get the numbers, or constants, I'm going to call them numbers, on the other side. So let's take this first example. We only have numbers on this side, so we're going to leave them. But we got x's here and x's here, so we want to get them all on the same side. Since our numbers are already here, why don't we take these and move them to join these guys? So we're going to add 1.2x on this side, so this cancels. We're going to add 1.2x on this side. So now on this side we have 1.2 plus 0.8, that's 2x, equals 5. Now a simple one-step equation, divide by 2, divide by 2, you get x is equal to 5 over 2. Okay, if you want to put this in decimals, there is decimals in the question, I would leave it at 5 over 2. If you put it at 2.5, totally fine. Okay, moving on, I'm going to erase and scroll. And we're going to go through these two examples here. Now, both of these examples here have fractions. I've taught you that you could do it two different ways. You could deal with fractions, or you can clear the denominator. For this first one, I'm going to do it both ways. Okay, I'm going to show you both ways, but each way will come up with the same answer. This one, I'll talk to you about that after. So some of you may look at this and go, I'm going to get rid of this first. I'm going to add 5 to both sides first. Yeah, that's okay. You can do that. Add 5. I want to add 5 here. Now, we're dealing with fractions. So that's really 5 over 1, but we need to add fractions, so we need the same denominator, which means that this has to be a denominator of 3. So I'm going to erase this right now and replace this with a 3. So I'm timesing this by 3. Timesing this by 3 gives me that. That was wrong. What am I doing? Is that wrong?
No, that's right.
Oh, that was right. Yeah, I'm second guessing myself. Okay, so this now cancels. We're left with 3 over 5x equals 17 over 3. Now, x is being multiplied by 3 over 5, so we're going to divide by 3 over 5. Divide this side by 3 over 5. X is equal to, now, here we have a division, which means we keep our fraction the same here. We switch this to multiply, and we flip this fraction upside down. You cannot cross reduce here, it's impossible, so we just multiply, top times top, bottom times bottom, and we get x is equal to 85 over 9, done. That is the fraction way. The second way I'm going to do then is clearing denominators. I'm going to rewrite the original question. We have two denominators here, a 5 and a 3. So lowest common denominator is a 15. So we're going to multiply every term, including this one, by 15. 15. 15. Please make sure the 15s go on the top. Now to cross reduce, just like I've always showed you here, 5 goes into 15 3 times. 3 times 3 is 9x minus 5 times 15 is 75 equals 3 goes into 15 5 times. 5 times 2 is 10. Now we're going to add 75 to both sides. We're left with 9x is equal to 85. Divide by 9, divide by 9, and we get our x is equal to 85 over 9. So as you can see, you get the same answer depending on which method you prefer.